Hello students, in our last lecture we studied about the group number 16 element, and we know that which elements are present in group number 16 like oxygen, sulfur, selenium, tellurium and polonium, and we also go through the chemical reactivity of group number 16 element, and it is very easy. Now, in this lecture, we are going to study about the different type of the compound that is formed with the help of group number 16 element. So first take a look of preparation properties of oxygen. Dioxygen, O2. First one is the preparation. How this dioxygen is prepared? So first preparation is laboratory preparation. Laboratory preparation. So in this laboratory preparation, potassium chlorate on its heating gives KCl, potassium chloride plus 3 moles of oxygen. So this is considered as laboratory preparation of dioxygen. Now the next laboratory preparations of the dioxygen. The dioxygen is also prepared by the decomposition of hydrogen peroxide. So this hydrogen peroxide, on its decomposition, in presence of any metal catalyst and in the presence of MnO2. In this reaction, MnO2 is also act as catalyst. So in the presence of MnO2 and metal catalyst, this H2O is decomposed, H2O2 is decomposed in H2O plus oxygen is released during the reaction. So this is called the laboratory preparation of dioxygen. Now the industrial preparation. Industrial, it means it is also known as large scale preparation. Industrial preparation of dioxygen, because in industry we manufactured any compound in large quantity. So industrial preparation of dioxygen, it is obtained by the electrolysis of water. So this water, on its electrolysis reaction that take place between graphite electrode, so the electrolysis reaction that take place between the graphite electrode, so this H2O2 is dissociated into H2 plus oxygen. This O2 is obtained at anode, while this H2 is obtained at cathode. So hydrogen is obtained at cathode and the oxygen is obtained at anode. Now this dioxygen is also prepared by liquid air. It is also prepared from liquid air by removal of, we know that in air many components are present. So by removal of carbon dioxide and water vapor, dioxygen is also opting. So here this is called the preparation of dioxygen. Now the next point is properties of dioxygen. Properties. So we know that the dioxygen is properties of dioxygen. Dioxygen is colorless, odorless and tasteless. Dioxygen is colorless, odorless and tasteless. It is soluble in water and it is heavier than air. Heavier than air. It having three isotopes. What is the meaning of isotope, student? Isotopes, it means what? The species which having a same atomic number but the different atomic mass is called isotope. Like oxygen having a same atomic number 8 but it having a different atomic mass. So this is called the isotopes of oxygen. Oxygen is paramagnetic in nature. Having a which type of the magnetic nature? So it having a paramagnetic nature. It means it possesses unpaired electrons. So this oxygen, dioxygen possess this type of the paramagnetic nature. Okay, along with this, students, dioxygen can also react with O2, can react with metal as well as non-metal and semi-metal, except noble metal like Au and Pt. So first, the reaction of oxygen with metal. Reaction with metal like calcium on its reactions with the oxygen gives calcium oxide. CaO is called calcium oxide. Calcium oxide. Okay, next is sodium on its reactions with the oxygen gives what? So it gives student Na2O, sodium oxide. Similarly, magnesium on its reaction with the oxygen gives magnesium oxide. Like metal, oxygen can also react with non-metal. So reaction with non-metal. Carbon, non-metal, on its reactions with the oxygen form carbon dioxide. Next, sulfur on its reaction with oxygen form sulfur dioxide. Similarly, phosphorus on its reaction with oxygen. Similarly, phosphorus on its reaction with oxygen gives phosphorus pentoxide. P4O10 gives phosphorus pentoxide. So this is reaction of dioxygen. Now simple oxide. Simple oxide. Oxygen on its reactions with metal non-metal and semi-metal form the binary compound. Form binary compound in which the oxygen is act as an oxide. So first in this topic here we are going to study about acidic oxide. Like we studied in last topic, oxygen on its reactions with metal, non-metal and semi-metal form the binary compound acidic oxide. Remember this, student, the oxides of non-metallic oxides are always acidic in nature. Example, non-metal like carbon dioxide, sulfur dioxide. So this type of the non-metallic oxides are always acidic in nature. Like sulfur dioxide on its reactions with H2O form what? So it form H2SO3, and this H2SO3 is called sulfurous acid. Next is basic oxide. Remember this, student, the metallic oxide are always basic in nature. Example, CaO metallic oxide, Na2 metallic oxide, MgO are metallic oxide, and this type of the oxides are basic in nature. Like CaO, calcium oxide, on its reactions with the water gives what? CaOH twice, calcium hydroxide, and this type of the calcium hydroxide is also basic in nature. So we can say that this type of the basic oxide are also or we can say that the metallic oxides are basic in nature. The next is amphoteric oxide. Amphoteric oxide, it means what? Some metallic oxide possess the dual nature. Some metallic oxide possess dual nature. It means it is react with acid as well as base, like Al2O3. Example is Al2O3, aluminium oxide. So this Al2O3 on its reactions with acid, hydrochloric acid, in presence of water gives what? So it gives AlH2O6 plus 3 plus 6Cl minus is released during the reaction. So this aluminium oxide can react with acid as well as it also can react with base. So this type of the oxide which can react with acid as well as base this is sodium hydroxide, or it is also known as caustic soda. So this aluminum oxide can also react with the base and gives what? Gives Na3 Na3 Al, OH, OH6, here 6 sodium, so this is 2. So it gives sodium tetrahydroxoaluminate. That gives you sodium tetrahydroxoaluminate. So this type of the aluminum oxide can react with acid as well as base. That's why this Al2O3 is called amphoteric oxide. Now fourth one is neutral oxide. Neutral oxide, it means what? Certain oxides are neither acidic nor basic. So this type of the oxide are called neutral oxide. Neither acidic nor basic is called neutral oxide. Like example of this neutral oxide, example NoCO and N2O, nitric oxide, carbon monoxide and nitrogen 2 oxide. Okay, now next, is mixed oxide. What is the meaning of mixed oxide? So student, in certain oxide, some oxides possess cation having more than one oxidation state, oxidation state. Like example, very easy, Pb3O4. Pb3O4 is called plumbic oxide and it is obtained in form PbO, Pb2O3. Remember the name of this compound? It's called plumbic oxide. Very easy, student. Now in this case Pb3O4, this PbO having a charge +2, while this Pb which is present in Pb2O3 having a charge +3. Next example is Fe2O3. What is the name of the student? Fe2O3 is called hematite. And this Fe2O3 is present in form of FeO into Fe2. So next example is Fe3O4, iron oxide, and it is present in which form? So it is present in FeO.Fe2O3. In this, the oxidation number of this Fe is +2, while the oxidation number of this Fe is +3. So this is called mixed oxide. Now after this mixed oxide, one more topic is given, is called ozone. So first of all, student, now we are going to study about the preparation of ozone. O3. So first preparation, very easy. Preparation. How this ozone is prepared in laboratory? Simple, by passing stream. By passing stream of oxygen through electrical discharge. Through electrical discharge, ozone is obtained. Like this is electrical discharge, and in this type of the electrical discharge, when we pass oxygen, so when we pass the oxygen, the ozone is obtained, and these points are connected with the batteries. So by passing a dry stream of oxygen through this type of the electrical discharge, the ozone is obtained. Chemical reaction, oxygen gives what? Ozone. So from this oxygen, ozone is obtained. So this is called the preparation of ozone. Now student, the properties of ozone. So the properties of ozone, very easy. Properties of ozone. So the ozone is obtained in the gaseous form, as well as it is also obtained in liquid form, and it is also obtained in solid form. But when it is obtained in the gaseous form, it possesses which type of the color? Pale violet. When it is obtained in the liquid form, it possesses dark violet color, and when it is obtained in solid form, it possesses violet black color. It possesses violet black color. So here you can also write the pale violet, otherwise you can also write according to your textbook pale blue color, and this is your dark blue color like your violet color. Okay, so this is the properties of ozone gas. This ozone, the lower concentration of the ozone is not harmful, but the concentration of the ozone, if the concentration of ozone is exceed to, it means we can say that if it is more than 100 ppm, then that create problems in breathing. That is also responsible for headache, and it is also responsible for nausea. So if the concentration of the ozone is more than 100 ppm, then it creates problem in breathing. It is also responsible for headache and nausea. This type of the ozone also possesses the characteristic smell, and ozone O3 is powerful oxidizing agent. It is also powerful oxidizing agent. Example: lead sulfate on its reactions with ozone, gives what? Gives this is lead sulfide on its reactions with ozone gives lead sulfate, plus during this reaction oxygen is released. So on the basis of this reaction we can say that this ozone is powerful oxidizing agent. तो ये खुद जो है वो पावरफुल ऑक्सीडाइजिंग एजेंट की तरह काम करता है. ओके, नाउ इन दिस ओजोन इट इज ऑल्सो like quantitative analysis of ozone. In our laboratory we carried out two type of the analysis. First one is qualitative and the second one is quantitative. In quantitative analysis we measures the quantity of particular substance. So this is called the quantitative analysis of substance. And in this quantitative analysis of ozone, example of this quantitative analysis, nitric oxide, which is emitted by the exhaust of a supersonic jet. We know that. So this nitric oxide on its reactions with ozone, which is present in atmosphere, so this nitric oxide gets converted into nitrogen dioxide. So it gets converted into the nitrogen dioxide. Nitrogen dioxide में ये convert होता जाएगा and during the reaction oxygen is released. It means what? This nitric oxide which is obtained by the exhaust of supersonic jet. So this nitric oxide on its reactions with the ozone, it converts the ozone into the oxygen. It means that deplete the ozone layer. Second, the ozone layer can also be depleted by depletions of ozone layer. So for the depletions of the ozone, which type of the other gases are also responsible? We can say that the Freon and CFC. What is the full form of CFC? CFC, it means chlorofluorocarbon, and the Freon is also responsible for depletions of ozone layer, and this type of the substance we use as coolant in refrigerator. Okay student, now structure of ozone. So ozone possesses which type of the structure? Structure of ozone having this type of the angular structure. It also possesses resonating structure, and the bond length between the two oxygen atom is 128 picometer. Here this oxygen, it having 1, 2, 3, 4, 5 and 6 electron. This oxygen 1, 2, 3, 4, 5, 6 and 7. It means it possesses one more electron, that's why it gain negative charge. While this oxygen 1, 2, 3, 4, 5, it possesses one less electron, that's why it gain positive charge. Same here, 1, 2, 3, 4, 5, 6, 7, so it gain negative charge. While here this possesses 6 electron, and the oxygen which is remain at the center point possess one less electron, that's why it gain positive charge. This is a resonating structure of ozone having a bond angle is 117 degree, while the bond length is 128 picometer. Now the next is allotropes of sulfur. Now In this allotropes of sulfur, allotropes of sulfur. The sulfur having two allotropes. Which two allotropes, student? First is called alpha sulfur. It is also known as rhombic sulfur. While second one is called beta sulfur and it is known as monoclinic sulfur. This alpha sulfur converted to the beta sulfur when the temperature is above 369 Kelvin, and this beta sulfur converted to alpha sulfur when the temperature is below 369 Kelvin. So in this point, 369 Kelvin temperature is called transition temperature. When the temperature is above 369, then the alpha sulfur gets converted to the beta. If the temperature is lower than that, then the beta sulfur gets converted to alpha sulfur. Now in this topic, first of all, here we studied about the alpha sulfur. So the alpha sulfur. Alpha sulfur. This alpha sulfur, it is also known as rhombic sulfur. And this rhombic sulfur, it is yellow color substance having a specific gravity 2.06. Next point, this type of the alpha sulfur is obtained in acid molecular form. Next, this alpha sulfur, it is stable at room temperature. Next point, this alpha sulfur is stable at the room temperature and it is also insoluble in water but soluble in carbon disulfide.